Alright, so we're going to take a look at this math task, and it's going to be kind of different. I'll give you some time, so if our guest teacher could pause it when I ask and give us, the minutes, and if you guys could try it, then we can look at, taking that and kind of trying to replicate what we do in class. So, you should all have this one. If you don't, make sure you go over and grab it. So, the first question I want you guys to do, and we'll give you about 5 minutes, is that I want you to write everything you know about this polynomial, this graph. Okay? So write everything you know about this graph, and we'll give you about 5 minutes to do that. So you can hit pause now. Give them about 5 minutes. Alright, so hopefully here's some things you came up with. Now there's some more we can probably write with this, so let's take a look. So hopefully you notice the relative min and the relative max. Relative min right about there, relative max right about there. Now I kind of estimated the points. If you got something pretty similar, that works. Okay, so we've got those. Those minimums and maximums help us identify the increasing and decreasing, right? So decreasing from negative infinity, we go down to that minimum. So negative infinity to 2.1. Then we jump, and we start up again right there. From 1.8, the maximum, to infinity. So the increasing was just from the minimum to the maximum, right? That's where it's going up. The increasing, the decreasing. Okay, we also had the positive and negative. Remember, positive is above, negative below. So it was negative from this point to this point, from that x-intercept to the x-intercept, right? Negative 3 to negative 1. And then from positive 2 onward to positive infinity. Okay? That's when it was negative. Positive started clear up at negative infinity to that point, negative 3. Then started up from negative 2, or negative 1 to 2. So that's positive, negative. Okay? Now, we also have the end behavior, right? So as we went to the left, as x approaches negative infinity, where are we going? We're going up. So we're going up to positive infinity. Okay? Now, as x approaches infinity, as we go to the right, our graph goes down. Our f of x goes to negative infinity. Okay, there is that end behavior. So could we figure out what degree this polynomial is? That's something else we could have written. Well, it's an odd degree, right? Because it's switching. We can see that it has 3 zeros. Okay, then we could look, are any of these zeros flattened? Are any touching? So when we think about that multiplicity, okay, looks like they all have a multiplicity of 1 because they just touch, or they just cross, and there's no flattening out, which would mean we have a third degree polynomial, 3 factors, right? So it's a cubic, so we can name it. Okay, we could also write the factored form of the equation with these zeros, right? So we've got the x-intercepts, the roots, the zeros. We can use those, remember? So we could go f of, sorry, I think there's a little problem there. We could go f of x equals x minus 2, remember we think about opposite, times x plus 1 times x plus 3. Okay, we can just write an equation using those factors. Now, there could be a number out here in front that we don't know about, and we'd have to do some more work to figure that one out. But we can at least get a pretty good idea what it's going to look like. We could even multiply those out to put it in standard form to double check. We've also got a y-intercept, 0, 6. It doesn't have any other fancy names. Okay, and then we can decide if it's a negative or a positive based off that end behavior. Okay, so since it's odd and cubic, now we got to just decide which side should it be. Okay, and the way to remember what it normally is, when we've got just the x cubed, it's normally like that. Okay, the way to think about it normally is, as we go to negative infinity, we go to negative infinity. As we go to positive infinity, we go up to positive infinity. So they're the same. Okay, are ours the same? No, they're opposites, which means it's a negative. So I could even put a negative in front of there. Okay, so that's a lot we can tell just from looking at this one graph. Okay, thinking about those things we've we know. I don't know why I erased that. Alright, so number 2 says, in the case this was not part of what you wrote in question 1, use function notation to highlight values of importance for this function. Okay, what does f of 0 equals 6 mean? Well, that means as the x value is 0, the output, the y value is 6. That's our y-intercept. So we could do the x-intercepts, right? We could write f of 2 equals 0. F of negative 1 equals 0. Okay, the maximum and the min you could write just like that. Okay, just kind of as the ordered pair but in function notation. So number 3 says, the graph above gives us quite a bit of information to assist in writing the equation. What if instead you have a polynomial function written out in standard form and are given one factor? How could you determine the graph of the function? Okay, so think about what we just did. That's what can be helpful. Okay, so that long division can help us determine the other factors. Okay, so it says for each one factor of a cubic function is given. Do your best to find the remaining factors and then use this information to determine all roots of the function and sketch a graph. Okay, so they don't want us graphing it first, because obviously we could graph it, find those roots, find those zeros, and go from there. Okay, that would be something we could do fairly easily. But we don't want to do that. Okay, we're kind of thinking going backwards, like we can't do it that way. Okay, so we want to find the factors and then use some basic information to sketch it. Okay, to help us find the factors, that's where the long division comes in. So I'm going to do this first one with us just to remind us how we do long division. Then we'll give you time to do a couple others and kind of go from there. Okay, so remember, with long division, the factors, the number we put in front, the equation, the number we put second under the division bar. Then we look at the first numbers. How can we make them the same? Well, how can x become x cubed? Well, we've got to times it by an x squared. Because we have two terms, we put the x squared right there. Then we times it to see what that becomes. X squared times x is x cubed. X squared times 3, 3x squared. So we go x cubed plus 3x squared. Then we subtract. So we end up getting x cubed minus x cubed is 0. 3x squared minus 3x squared is 0x squared. Okay, which can happen. Bring down the negative 4x. Okay, so how can x become 0x squared? This one seems kind of odd, but we'll get rid of that later. But just for now, we're putting it in there as a placeholder. Okay, so we times that together, and we get 0x plus 0, right? So minus that, basically we get rid of that one, and we end up with negative 4x still. Bring down the negative 12. Okay, how does x become negative 4x? Well, times it by a negative 4. This one's kind of odd, isn't it? So we get negative 4x minus 12. So negative 4x minus 12, they're the same thing, right? So if we minus, they both become 0. That's what we want to end up with. So we have a factor. Okay, now what do we do with that? So we know it's a factor, which they told us it was, but by doing that division, we essentially took this standard form and we pulled out the x plus 3, and what was left over was x squared plus 0x minus 4, or x squared minus 4. Okay, so it's probably going to be beneficial to leave it in that other way. So let's think about this box method style. How are we going to figure this one out? Well, because we want to factor this down even further. And I guess actually we don't need to do it with the box method because we don't have that middle term, do we? Okay, if we're thinking about these as factors, we can set them equal to 0. Right? And then we solve to find the roots. So we'd have x plus 3 equals 0 and x squared minus 4 equals 0. Okay, Now, this x squared minus 4, that's a quadratic term. It's not linear. Okay, but we can still use it to find our roots. So we can subtract 3 for this, so we get x equals negative 3. For this one, we would add 4. X squared equals 4. Take the square root, and we get the positive 2 and the negative 2. So we have our two other factors, positive 2, negative 2. Okay, now can we use that to draw the graph? Yeah, and this is kind of how we would think about it. Okay, so we've got the roots. We know that none have a multiplicity, right? So let me find a graph for us. Alright, so here we go. So we've got this graph. We've got our function. So I know that my roots are negative 3, positive 2, and negative 2. I also know that they all have a multiplicity of 1, right? There's no other powers here. And I know it's a positive cubic. So I know at the furthest right, what is its end behavior going to be? It's going to shoot up somehow. I also know at the left, it's going to shoot down somehow. Okay, so I'm going to cross, jump over here, fall back down, cross, kind of fall back down, something like that. Okay, using the roots and the end behavior and that idea of the multiplicity, we can then draw a pretty simple graph with it. Now, is that exactly right? No, but it's pretty darn close. I just don't know how quick it goes up or how far it goes down. But for right now, we're not too concerned with what's happening right there and right there. We're concerned with these guys, and we should also have a good idea of what's going on there. Okay? So, what I want you guys to do, try to do that same thing for number 5, number 6, number 7, okay, and number 6, yeah, try that one. Okay, we'll take about 5 minutes, see how far we can go. So now would be the time to pause it, give them about 5 minutes, and try to get as far through these as you can, okay? After the 5 minutes, we'll just kind of take a look at where we ended up. Alright, so for number 5, we do the same thing. Hopefully you already did this, and it's been 5 minutes for you, but only like a second for me. Okay, so this is a factor. So by doing this, this up here is going to be an easier to factor quadratic usually. Okay, and that helps us out. So, x squared would get it. I'm going to probably go a little faster here. So x squared times x is x cubed. X squared times 1 is just 1x squared. We subtract 0. 6 minus 1 gives us 5x squared. So bring that 11x down. How does x become 5x squared? Well, got to have a 5 and an x. 5x times x gives us 5x squared. 5x times 1 just gives us 5x. Subtract it, we get 0. 11 minus 5 gives us 6x. Bring down this positive 6. And what does it take to get 6x? 6. So 6x plus 6, right? So we knew that would come out nicely, proving that it is a factor. But now we've got this. Our equation now, instead of being standard form, we've started to factor it up. Okay? And that's the purpose. Now, we can take this quadratic term and we can split that up even further by factoring using our box method. Okay, so factors of 6 that add up to a 5. Okay, can we find them? Well, 1 and 6 won't work. Negative 1, negative 6 won't work. How about 2 and 3? Yep. So we factor out x, 6 is like 3 times 2, positive 2, positive 3. So now, this factors out to x plus 2 times x plus 3. Okay, so our roots are -1, -2, -3. Then you can take and try to graph it that same way. Okay, have roots here, here, here. It's regular positive, so something like this is what it's going to look like. Okay, so let's take a look at the rest. So taking a look at number 6 now, we do the same thing. So, how can x become x cubed? Times it by x squared. It gives us x cubed minus 3x squared. Subtract, and that gives us 6x squared, right? 3 minus a -3. It's really like plus, so we get 6x squared. Bring down a -12x. How can that work? Well, x becomes 6x squared by going 6x. 6x times x. 6x squared, 6x times -3, -18x. Minus it, -12 minus -18, it's like plus, gives us a 6x, and that cancels. So we add a 6, 6 plus x gives us 6x, 6 times -3, and I said plus, didn't I? 6 times x, 6 times -3, gives us a -18. Oops, getting ahead of myself. Bring down the -12, so we get 6x minus 18. Okay, now what you should notice, this one comes out to be a positive 6. Okay, so that means it's not a factor. So apparently there was a typo in the person we got this from. So, but this is useful to know. What that tells us is this 3 is going to be equal to 6. It's like extra information. It's like a point. Okay. Now, to figure out the roots, you're going to have to try something different. But let's not worry about that one today. Okay? So, let's take a look at the next one. Now, we've got an x minus 2i. Okay? It's going to make things a little trickier. And actually, for what we're doing right now, let's bag that one for now. When I get back, we'll talk about that one. But, I'd rather not have us get too confused with that when we're still dealing with this other stuff. Okay? So, number 8, how would we deal with that one? Okay? Well, we take a look at it and we go, same thing we've been doing. X minus 3 divided into x cubed minus 3x squared minus 3x minus 9. Okay? Times it by x squared, because x squared times x gives us x cubed. X squared times -3, -3x squared. Subtract -3 minus -3, that's like the plus. Okay, so -3 plus 3 gives us 0x squared. Bring down a -3x. Okay, and what you can kind of think, if you don't want to have to deal with this one, because they both cancel out, okay, what you can think of is, okay, we've got like a 0x here, and let's move on to the next one. Bring down the next one. So how does x become a -3? Times it by -3. So we get -3x, -3 and -3, a positive 9. Okay, subtract that, and we get 0 for this one, and a -18. Right, we do that one right? Hold on. Maybe we can't do that shortcut. I thought we could. I was thinking we could do that, but maybe I might have screwed something up. Let's take a look just to be on the safe side. So that would be 0 x squared. So we times by 0x. So we get 0x squared plus 0. Then we'd minus. So we'd end up with -3. X. So yep, -3 times x would give us -3 x, and -3 times -3 gives us a positive 9. So yeah, that one ends up not working either, does it? So we get a -18. So once again, that one didn't really help us out. Okay, didn't really help us out. But I wonder if we could do the box method, because when you run into this, you know, that's going to give us some problems, because now what do we do? How do we factor out this? Well, it's another method we can try is the box method. So we've got x cubed, negative 3x squared, negative 3x, negative 9. So I could pull out an x squared, pull out an x. We run into an issue, don't we? That negative 9, we can only pull out one of them, right? Which would leave us with, that's where we run into our problem. So, I'm going to have to double check on that one to see exactly what we have to do. But for right now, let's move on. Okay. So, if we take a look at number 9, it says find all linear factors in graph. Okay. Well, this one is actually, I don't know if you guys learned this last year, the difference of perfect squares. X to the 4th is like x squared squared, and 16 is like 4 squared. There's a special rule for the difference of squares. Okay. That rule is that it's basically, if we called this A and this B, it'd be A plus B times A minus B. In other words, if we went x squared plus 4 times x squared minus 4, that would get us our factors. If we multiplied that back out, we'd end up getting to that. Okay? Now, the same with this one, you know, that one we could then factor it out. This one, if we factor it out, we're going to run into issues. Because if you think about solving it, we get x squared plus 4 equals 0. We'd minus 4. And so we'd take a square root, and we'd have the square root of the negative number, so we'd end up with 2i. Positive negative 2i. Okay, so we're going to end up with an imaginary root, which sometimes happens. Okay? Sometimes happens. Next time when I come back, we'll talk more about it. I can go over a few things with it. I didn't know this would have so many imaginary roots. Sorry about that. But let's not worry about the imaginary roots. Okay? So let's keep looking. So kind of the main idea that I wanted to come away with was number 5 was probably the best version of that, wasn't it? And number 4. So hopefully you at least got number 5. But the main idea here is that by knowing one factor, we can then find the others, give our roots, and then graph it. Okay, let's not worry about the rest of this for right now. Okay, that's going into some deeper stuff that I don't know if we're quite ready for. I want to make sure that I'm here to talk to you about, because they can be very confusing. Okay? But regardless, you end up dealing with less. So, part 2, given the roots, find the factors and write the polynomial equation in standard form. So this is kind of working backwards. So remember, positive means negative, in parentheses, negative means positive. Well, on x equals 0, it'd be like x minus 0, which that would just simplify to x. Okay, so we could have this, and then we could multiply it out. X times x gives us x squared, x times 4, 4x, minus 3x, minus 12, all that times x. Then simplify those, we'd have x squared plus x minus 12 times x to everything, so x cubed plus x squared minus 12x. That's our function in the standard form. Okay, that's essentially what it's wanting you to do, is take that and go with it. Okay, so I think that's what all I want you guys to do for right now, is to go that far. and we'll take a look at the homework and kind of go from there to see what's happening. And we'll probably talk about this next time a little bit more as well. We'll talk about stuff like this. I just want to make sure I'm here to talk about that stuff with you guys. Okay? So, let's use a different example. Let's just go with this one, but 5 and 2 and -2. See if you can do the same thing I did to number 10. Okay? So take about 5 minutes, 6 minutes, try that, and then we'll, so hit pause, try that on your own, and I'll show you that as one last problem. Okay, so hopefully you tried this one out. So we take all these factors, we'd have x minus 5 times x minus 2 times x plus 2. Then we start by multiplying them out. X times x gives us x squared plus 2x minus 2x minus 4. Those cancel out. We get x squared minus 4 times x minus 5. Times that, x cubed minus 4x minus 5x squared plus 20. Then we probably just want to rearrange it. Go x cubed minus 5x squared minus 4x plus 20. And there's our function in standard form. Okay? So, I think that should be good enough for now. Okay? So, what I want you guys to do, I want you to write this on that piece of paper and bring it to me next time and just talk about what are a few things, simple things that we learned about polynomial functions. Okay? So, take a few minutes to do that. Make sure you got the homework. Start working on that in class. I should have a video up as well. Maybe you can, if you have time, you can even watch the video on the homework in class. So there we go. Hopefully that wasn't too annoying.